Alright fellas, so in this problem, we're gonna have to evaluate a reverse Polish notation, aka a postfix notation. Now, upon seeing the title of this question, a very valid question is what the fuck is a reverse Polish notation? I'm just gonna call it postfix notation from now on, because it's more sensible. Regardless, it's a type of arithmetic expression where the operator is placed at the end instead of it being sandwiched in the middle. So technically, in the math world, this is called an infix notation, and this is called a postfix notation. Regardless, we can't really solve this problem unless we really understand what the postfix notation is like. So let's have a look at some examples. On the left here, we have a normal expression, 1 plus 2, and you can see that when it's rewritten, it becomes 1, 2, and a plus. So how you'd want to read this is that, okay, we have the first number, we have the second number, and then we don't really know what we're going to do with these two things yet until we encounter this plus, which will fill in the gap in the middle. Be like, oh yeah, they want us to add this. So that's 1 plus 2. What about this one? Well, on the left, we have 1 plus 2 times 3, and we know that multiplication takes precedence over addition. So this doesn't become 3 times 3, this becomes 1 plus 6, right? The nice thing about postfix notation is that we don't really care about the order of operations, because the order of operations is already encoded in the expression. So here, the first thing that's going to happen is 2 and 3. We don't know what we're going to do with it yet, and then we encounter this, and that's going to be a multiply. So that's going to give us a 6. And then after we get a 6, we see a 1, and it's like, okay, there's like a 6 and a 1, but we don't know what we're doing with it. And then we encounter this plus, like, oh yeah, we want to add that. So the answer is 7, right? And this last one on the left here, we use brackets to indicate that we're going to evaluate this expression first, since the brackets will take precedence over the multiplication. And in the postfix world, we don't really care about brackets. The order of operations is clear as day. 1 and 2, we add that, and then the result of that with 3, we multiply it. So 1, 2 plus gives us 3, and then 3, 3, and to multiply, that gives us 9. Now that we understand how to evaluate this kind of notation, let's have a look at what they want us to do. So if you look here, they're going to give us a list of tokens, which represents a postfix notation. And our job is to evaluate this arithmetic expression and come up with a value. So let's think about how a computer would go about solving this thing. So let's say I do a for loop, and then I encounter the number 1, and then I'm here, I encounter number 2. As usual, we don't really know what we're going to do with it yet until we find an operator, the plus. So that's going to fill in the blanks, and that's going to give us 3. And then we're going to encounter 3, and then in the next element, we're going to encounter multiply, which is an operator, and that'll give us 9. And then we'll encounter a 4, and then a minus, which will give us an answer of 5. So that's a pretty simple example. If by looking at this example, you can already see the pattern. Numbers, and then an operator, and then another number, and then another operator, another number, another operator. Can we have like a bunch of numbers in a row, or a bunch of operators in a row? And the answer to that is yes. So let's have a look at a more extreme example like this, where we literally have 5 numbers in a row. Let's say we encounter an input like this. As you can see, we have 5 operands back to back to back. An operand is just a number, by the way. Only then are we given 4 operators back to back. What's this gonna look like then? Well, as we're going down the list, we encounter our first element, the number 1. And then after that, we will encounter the number 2. Now we have 1 and 2, but we don't know what we're supposed to do with them. Since we're not given an operator yet, well, that's fine. And then we encounter the number 3. Again, we don't know what we're supposed to do with 3, because these two are supposed to evaluate to something, and then that output is supposed to do something with 3, but we don't know. So I'll put a question mark. Same story with 4. What is 4 supposed to do with the rest of this? I don't know. And then 5. What is 5 supposed to do with the rest of this? I don't know. Now we're finally given an operator, this plus. So where's this plus expected to go into? Well, if you ignore all the question marks here, you'll see that when we encounter a plus, it'll be like this, right? So this plus is going to be acting on the 4 and the 5. So this will give us 4 plus 5, like so, right? Or 4 plus 5 if you prefer the postfix notation. So our postfix expression is going to evaluate to this, right? 4 plus 5, 9. And then we encounter the next operator, a minus. And likewise, minus is going to be acting on this guy and this guy. So it'll be 3 minus 9, which will give us negative 6. 1, 2, and negative 6. And the next element is plus. This plus is going to be acting on these two. So 2 plus minus 6, which is minus 4. We have 1 and minus 4, and then we reach the final operator, which is a minus. And minus is going to be acting on these two, so it will be 1 minus minus 4. 1 minus minus 4 is positive 5. And that is our answer. Now, if you paid attention to what we've been doing so far, doesn't this feel kind of like a stack? Because initially, as we're going through the operands, 1, 2, 3, 4, 5, you can think of them as just appending to the stack. And only once we encounter an operator do we try and remove the last 2 elements and do something with it, right? We kept adding numbers, and then we encounter the plus, and then it's like, oh, plus is gonna do something with these two. So I'm gonna pop these two from my stack, add them together, and then the result, I'm gonna shove it back into the stack. Then we get a 9. And then once we encounter the minus, it's gonna grab this and this, minus them together, and then shove it back into the stack. Same thing with this and this. And just with that knowledge, we're ready to write some code. So first of all, let's define our stack. I'm just going to say it's an empty list. And as we know, inside our input array, we're going to have operands and operators. So we'll need a way to distinguish whether it's an operand or an operator, right? So I'm just going to make a set real quick of all the operators, like a plus, minus, multiply, and divide. Then we want to process every single token for token in tokens. Now what we're gonna do is, we have two branches basically, right? So one branch is that if token is an operator, and the other branch is if the token is an operand. So I'm just gonna say that if token in operators, then it's an operator, and then we'll have another branch for if it's the number. Now if it's just a number, then, well, all we do is stack.append integer of token, right? Because remember, everything's going to be in string format. So once we encounter these numbers, we want to add the integer of it. We want to first cast it into an integer before adding it to the stack. And what about our operators? Let's say this is our input, just a simple 1 minus 2. So we're kind of at the stage in the iteration where we've encountered this minus and 1 and 2 has been appended to the stack. And then we encounter this minus. What do we do? Well, first of all, we gotta pop these two, right? So I can say a, b is equal to stack.pop and stack.pop. And then I can add a statement that goes like, if token is equal to minus, then we're gonna add the result of that back into the stack, right? Stack.append a minus. But there is a bug in writing our code like this. Why is that? Well, because it's a minus, the order of operation matters. 2 minus 1 is very different from 1 minus 2. And if we write our code like this, when we do stack.pop the first time, it's going to give us the number 2, which is the second value actually. And then our second pop is going to give the number 1, because when you pop from the stack, it gives you the last element. So in effect, A will be 2 and B will be 1. So it'll be 2 minus 1 instead of 1 minus 2. To fix that, we just flip it around. So that was all I wanted to show you in terms of order of operations. Then we can kind of fill out the if-else chain with the other operators. If token is equal to plus append the result of the addition back to the stack. Stack.append A plus B. And of course, this has to be elif now. And multiplication is kind of the same deal. Now for division, if you just do a divided by b, this is actually going to give you a decimal, possibly. Like if a happens to be 5 and b happens to be 3, this will give you like 1.666 blah 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 blah, right? So to avoid having floats, there are actually two ways to go about this. Well, the first time I was solving the problem, I was like, oh, okay, I'm just gonna do the double slash. And doing double slashes is actually wrong. If you look at the requirements, it says that assume that the division between integers always truncates towards 0. Well, how floor division works is that it's going to floor the result to the lowest integer, right? So for example, 5 double slash 3, usually 5 divided by 3 will give me 1.666 whatever. And then when I floor division this thing, it's gonna floor this to the nearest lowest integer. So here, since this number sits between 1 and 2, the lowest integer here is actually 1, right? So in effect, this gets chopped off. 5 double slash 3 gives us 1. Okay, that's what we want. This is actually the expected solution. The reason why I say it's wrong is if it's a negative number. Let's say I have negative 5 divided by 3. Same deal, we get like negative 1.666 whatever, right? In a normal division. However, because double slash floors the result to the lowest integer, since negative 1.666 sits in between negative 1 and negative 2, the lowest integer now is actually minus 2. So this is going to get turned into minus 2, which is not what we want because we want division between integers to truncate towards 0. Well, so in effect, we really just want to chop off the decimals, right? So the best way to do that is not using floor division. The best way to do that is to do normal division, which will give us 1.66 or negative 1.66. And then we're going to convert this into an integer, which will give us the behavior that we want. It'll chop off the rest of the decimal points, leaving us with 1 or negative 1. So after executing all of this, we should ideally end up with just a single element in our stack representing the final value. So we'll just simply return the top of the stack. And there you go. Now, there are some edge cases that we kind of ignored. Even though our solutions still work, there are a few edge cases that we did ignore. We're kind of assuming that the stack actually has numbers to pop, right? We didn't have any like check. This is all assuming that we have like well-formed inputs, which the test cases seem to provide. But for now, I'll leave it just as is since it's been accepted. Okay, bye.